If you watched the previous videos, you saw that we were doing a bunch of, I guess, kind of random things using trigonometry. None of it kind of really fit together, and that's because really all those different pieces were made so we could do this kind of problem. Finding the sine, cosine, or tangent, or our reciprocal functions of many or all of the special angles we have on our plate without using a calculator. So let's kind of put all those individual pieces together and see how this works. So step one is I'm going to need a sketch of this original angle, and I'm going to need to find its reference angle. So that was one of the previous videos we took a look at. So let's make a sketch to figure out what quadrant this angle ends up in. Now it's a negative, so I'm going to rotate clockwise. I need to go a little bit past 180 because that's where I'm at. So I'm somewhere in quadrant 2 for this angle. That's going to be important later on. Now it said I also need to find the reference angle. Well, recall that a reference angle is the acute angle that's formed always between the x-axis, never between the y-axis. So I gotta kind of think, using some simple geometry, what that yellow angle is going to be. Well, halfway is 180. I didn't go to 180, I went to 240, and I'm going to ignore negative signs. The reference angle is something that's always positive. So I need to think, well, to get from 180 to 240, I must go 60 degrees farther. So my reference angle is going to be 60 degrees. For these problems, your reference angle is going to be one of your special angles, 30, 45, or 60 degrees, or it will be quadrantal. We'll look at that in our last example. So there's step one. I've sketched it. I found my reference angle. Step two, let's find our actual trig ratio. Most likely, you're probably going to use the chart we made in class. Since our chart does not include all the special angles on our plate, we've only included the 3 special ones, and there's a reason for that. I want to look up just the tangent of 60 degrees. We can use this, we'll see in step 3, to find the tangent of negative 240. So tangent of 60, according to my chart, is equal to the square root of 3. I don't use a calculator for that because I don't want a decimal. I want the exact value, and according to my chart, that's the square root of 3. My final step then is to determine the sine. So we watched a video about this as well. The sine of the sine SIGN depended on which quadrant the angle ended up in. We had all things positive, just the sine positive, just the tangent positive, or just the cosine positive. So depending on what angle my original, or depending on what quadrant my original angle ends up in, that's going to determine whether I'm positive or negative. So I have to make sure I use that original, not the 60 degree reference angle, because that would always be in quadrant 1. I need to use that original orange angle up here. That ended up in the S quadrant, telling me that sine would be positive and everything else would be negative. Well, I didn't find the sine, I found the tangent. So that tells me I'm going to have a negative sine. So my final answer after all this is going to be the negative square root of 3. I can check this using a calculator as long as I'm in degree mode. I can type in tangent of negative 240 degrees, and I can see that that comes out the decimal equivalent of this, negative square root of 3. All right, let's try a couple other ones just to make sure you got the idea. So step 1, I want to sketch this angle. This time it's in radians. If it helps you can convert to degrees, but I'm going to stick with this one and graph it in radians just to remind you how to do this. I'd recommend changing 17/6 into a decimal. That's what I like to do. The decimal comes out to be about 2.83 pi. And so what that tells me is I've gone 1 full time around the circle, because that's 2. I haven't made it quite to 3, which would be halfway, so I'm going to be somewhere over here in quadrant number 3. Except, nope, oops, I did that backwards. I was rotating clockwise again. I should be rotating counterclockwise for a positive. My mistake. So rotating counterclockwise, I've gone a complete lap around this way, and then I don't quite make it to 3, so I end up in quadrant 2. Sorry about that. Look at that. Even math teachers make mistakes. So my angle is in quadrant 2. The reference angle is easy to find. Remember, as long as it's a special denominator when you're in radians, which 6 is a special denominator, pi over 6 is going to be my reference angle, also known as 30 degrees. Okay, so step 2, I want to find the ratio that I'm looking for. In this case, we were asked to find the cosecant. So let's find the cosecant in our chart of pi over 6, or 30 degrees. Using my chart, I can see that the cosecant of pi over 6 is equal to 2. And then finally, I need to determine the sine, SIGN, to see whether this is a positive or a negative 2. So we're going to use the ASTC thing. I ended up in quadrant 2, which tells me that sine is positive and everything else is negative. With one exception, the reciprocal is also going to be positive, so cosecant. So I have to take a look and see what I did. This time I did the cosecant. So because I ended up in the quadrant that it's positive, my final answer is going to be a positive 2. And we'll take a look at one more that sort of, I won't say breaks the rules, but it doesn't follow these steps exactly. Let's see what's special about this one. So I want to graph 3 pi over 2. I can convert that into a decimal. That comes out to be 1.5 pi. Or if you look on your plates, 3 pi over 2 is on there. In fact, it turns out to be not in any quadrant, but it's actually just 270 degrees. It's a quadrantal angle. As soon as you get to something quadrantal, it's not going to follow these rules because it doesn't have a reference angle, and we don't have those ratios in our chart. So instead, we're using those coordinates on our plate. So if you take a look at your plate, I'm down here at 270 degrees. According to our unit circle, those coordinates were 0, -1. And what that tells me, you remember, is the x value always tells me the cosine, and the y value always tells me the sine. So this is what I'm actually going to do to find a quadrantal angle. They asked me to find the cosine of this, so according to that, I should just use the x value. The cosine of 3 pi over 2 is just going to be 0.